Okay, so whenever you're trying to remember the order that all of this goes in, I generally like to just use the periodic table and basically read it straight across. Okay, so a couple things you need to remember. Okay, this is your S block here. This is your P block over here. Okay, this is also contained in S. This right here is D. And then this here is F. Okay. Now, with each of these, for S and P, basically the number that's going to come in front of them is the number of the row that they're on. So, for example, this would be 1S, 2S, 3S, 4S, 5S, 6S, and 7S. And then P, over here, you start with 2P, 3P, 4P, 5P, 6P, and 7P. Okay, now with D, if you remember, the lowest energy level for each orbital is 1s, 2p, 3d, and 4f. Okay, that means that this top row here in the D block is 3d. This one is 4d, 5d, and 6d. Okay, and then because the lowest one for the F is 4, first up you have 4f and 5f. Okay, so that kind of labels it. And then you're just going to read it like it's a page in a book. Okay, so you're going to start right here and then just read from left to right. So first up you hit 1s, okay, and then you've gone all the way across and you go back to the next line, which is 2s. Hit 2s first. And you go across. And here you're going to hit 2p. Okay, start back over here. You hit 3s, go across, you're going to hit 3p. Then start here and you hit 4s. Next up, we have our first d orbital. So it is 3d. And then we have 4p here. Okay, start back here, 5s, 4d, and 5p. Now this is where things get a little bit tricky. Okay, so you have 6s, okay, but then you'll notice right here, you have a break in the periodic table. So it goes from here down to here. Okay, so this is where you add in your 4f. And then you go back up to your D. So 5D, 6P. Okay? And then you do the same thing here with the 7S. Jump down to your 5F. Jump back up to your 6D. And then finally you have 7P. Okay? So that's how the order of all of this works. So you can either learn it by doing the one with the diagonals and figure out the order that way, or I just always basically read the periodic table, okay? And you read it just straight across like this, right? Okay, so there is actually a shorthand version of writing electron configuration, and you will see why that is really nice and useful, especially with some of the bigger atoms that have, 80 to 100 to 118 electrons in them. Okay, it's kind of a pain to write out 1s through your 7p. Okay, so instead we have what's known as noble gas configuration. So basically this kind of cheats, and it says you're going to, I'll show you on the periodic table here. Okay, let me get rid of all of that. All right, so say we're trying to write the electron configuration for moscovium right here, 115, okay? Now, moscovium is in 7p, so literally you could write out all of this down here with all of your little exponents, okay? Just going through all of this. Okay, And then once you get to 7p, okay, so this is your first electron in 7p, this is your second, and here is your third, okay? So you could either write all of that out if you wanted to, or you can basically say, well, it has the electron configuration of radon right here, okay? So you can write radon in brackets and then add on to that. So instead of having your starting point up here with 1s, you move the starting point for where you're going to write to the noble gas of the row before, okay? And then you start from there. So radon goes up to 6p6, okay? So now you can just write everything after that. 7s2, 5f14, I'm running out of space, then 6d10, and 7p3. Okay, so that cuts out a lot of what you have to write through all of this. All right. Okay, so instead of writing out the entire electron configuration, you can use the noble gas configuration as a shorthand. So you write the previous noble gas in brackets and then write the rest of the electron configuration after that noble gas. So it really just moves the starting line. So you don't have to basically run the whole race, you can just run the last bit of it. All right. Now, if you are trying to figure out the electron configuration of a noble gas, if you're going to write the noble gas configuration, you still have to write the noble gas above it. So, for example, if we were going to use oganesson, this last one here, 118, okay, we would still have to write Rn in brackets. We can't just write OG in brackets and call it good. I know, it's kind of frustrating, but okay, so another example of how this helps out, the full electron configuration of silver looks like this. Okay, kind of a pain. The noble gas configuration, or the electron configuration for krypton, would look like this. Okay, so especially if you're typing this out and doing all of your exponents and everything, that takes forever to type it out. Okay. Now, if you use the noble gas electron configuration for silver, it cuts it down from all of this to this. Okay, you see how quick that is to write? You use the noble gas that is one row up from silver, which is krypton, okay, and then you add in the one part that is not included in krypton. Okay, so you'll notice in the electron configuration for silver and the electron configuration for krypton, you have 1s2, you have 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6. Okay, so it's basically a way of getting rid of all of that and only writing what's new. Okay. So definitely a shorthand version. So what is the complete electron configuration notation of zinc? So first up, you got to find zinc on your periodic table. Okay, and you will find that it is at the end of the first D block. Okay, now remember, we have to start with our 1s. So we have 1s. You basically, the way you can do this as well is you have 30 electrons total. Okay, so you just keep a running tally as you go through. So 1s2, okay, now we're down to 28. 2s2, now we're down to 26. Okay, 2p6, down to 20. Then you go up to 3s2, down to 18. And over to 3p6, down to 12. Then you do 4s2, down to 10. And then you have your 3d, and all 10 electrons go in there. And then you're out of electrons. Okay? Now, again, if you go through and add up all of your exponents, they will again add up to 30. It's a way to double check that your total number of electrons that you use in your electron configuration equals the atomic number of whatever atom you're doing. Okay? What is the noble gas notation for zinc? All right. So in this one, again, you look one row above zinc. Okay, so basically you're looking for the noble gas that has this electron configuration, and that turns out to be argon. So brackets Ar, and then you write what's left. 4s2, 3d10. Okay? All right. So write both the complete electron configuration notation and the noble gas notation for a rubidium atom. Okay? So first thing, you need to find rubidium right here. It has 37 electrons. All right? So again, you start up here. So you have 1s, 2 electrons in there, down to 35 electrons. 2s2, down to 33. And we're over here. We have 2p6. Okay, so down to 27. And then over here, we have 3s2. Got 25 electrons left. Then 3p6. So we're down to 19. Then we're here. We have 4s2 down to 17. And then we're going to go through D, the D orbital. So that is 3d10. Now we're down to 7. And you've got your 4p6 down to 1. And 5s1. Okay? And now we're out of electrons. Now what you'll also notice is that this should end with whatever this is. Okay? So this is in the S block. It's the first one in the S block, and it's also in the 5th energy level. So it should be 5s1. Okay? Which is what it ends with. So there's our entire electron configuration. Okay, now to write the noble gas configuration, this one's relatively easy. You go to the noble gas in the row 1 above where rubidium is. So the 4th energy level here. Okay, go across and you see krypton. So krypton in brackets. Okay, and that accounts up to 4p6. So now you just write what's left over. 5s1. Okay. Let me erase all of this. There we go. Okay. Identify the element with the following electron configurations. So you might be asked to write out the notation, write out the noble gas notation, or identify the electron. Okay. This is relatively easy because all you have to do is really just look at the end. Okay. You go to 5F, which is here. Okay, and remember, actinium and lanthanum are not part of the F block. They are part of the D block. Okay, so you go to F, and then you count over 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one is Einsteinium. Next one. You've got your noble gas configuration. So you start at 36 here, and then go up to 5p6. So this is 5p starting right here. It's 1, 2, 3, 4, 5, 6. That is xenon. And finally, you start with radon. Okay, that is your noble gas configuration. And then you go to 6d2. Okay, so 6d starts here. Okay, so 1, 2. Rutherfordium. All right, there you go. I can get my mouse to work.